Welcome to Spring LIB.
Okay, so here we have a mass attached to a spring and it is initially stretched at a distance x naught. So let us first write the equation for its displacement, that is x is equal to x naught. Now it should be cos omega t because at time t equal to 0, x should be equal to x naught, right? Now v equals to half its maximum velocity. So let us first find out the expression for v. So expression for v is equal to minus omega x naught sine omega t, right? And since we also need to calculate the acceleration, need to discuss about the acceleration, so let us also find the acceleration. So that is minus omega squared x naught cos omega t. So you should have known how I calculated this. To calculate v, I differentiated the displacement with respect to time, and to calculate a, I differentiated velocity with respect to time. All right. Okay, so now let's move on to the question. The first question asks us that at what distance from the mid position from the equilibrium will the velocity v should be equal to half the maximum velocity, v max, right? Now from this equation of v, uh, this should be equal to half of, so v max is what? Omega x naught minus omega x naught, right? And v should be equal to, which is equal to, v is what? Minus omega x naught sine omega t. Okay, let me write it the other way because we will not have space. So omega x naught minus omega x naught sine omega t, right? Now if you compare the LHS and RHS, this gives me sine omega t as 1 by 2, right? So this gives me, for that condition, omega 2t should be 30 degrees, right? That is pi by 6. I love pi by 6, writing pi by 6 instead of 30 degrees. Okay, so now at what distance would omega t be pi by 6? So x is equal to x naught cos pi by 6. Now cos of pi by 6 is 0.866. So therefore, the distance from the origin would be, the distance from the equilibrium would be 0.866 x naught. So this is it. So let's move on to part B. In part B, the acceleration should be half of a max. A max, right? So this implies that acceleration is what? Acceleration is minus omega square x naught cos omega t should be half of omega square x naught, because that is the maximum acceleration. Now if you compare the LHS and RHS, this gives me, this is negative, okay? So cos omega t seems to be equal to 1 by 2, right? Now plug this in the expression of x is equal to x naught cos omega t, so x naught into half. Therefore x is equal to 0.5 x naught. At this position the acceleration would be half. Okay, so this ends the solution to this question. Thank you for watching.